it's Karn. I'm one of the science educators at the Air Zoo. Sun is in the forecast, so I thought it would be a great time to do a little more solar science. We're going to learn how to tell time using an ancient device called the sundial. So remember, in an earlier video, we observed that shadows cast by an object move throughout the day, and also the shadows get longer or shorter depending on the time of day. And remember, it seems like the sun is moving, but it's actually the earth spinning counterclockwise on its axis and orbiting around the sun. So people have been making sundials for over 3,000 years, maybe even longer than that. The earliest sundials were found in Egypt's Valley of the Kings, dating to 1500 BC. And about 1500 years before that, the Egyptians were building tall structures called obelisks that would cast shadows and also be useful for indicating the time of day. Picture the Washington Monument, but in the Egyptian desert. A lot of different cultures figured out how to make sundials. So those cultures included the ancient Greeks, the Romans, the Chinese, the Babylonians in an area now known as Iraq. A sundial has two parts. You need something to cast the shadow, and you need something to cast the shadow on. So the thing that casts the shadow is called a nomen. And I always kind of picture a garden gnome because they have similar spelling. The thing that the shadow is cast upon is called the dial or the plate. And it usually has the markings that indicate the time or the subunits of time that you want to be measuring. So simple sundials, in a simple sundial, the dial or plate is flat and it's either mounted horizontally or vertically on a wall. But more complex dials can have like a curved plate or other kind of more complicated shapes. There's even a bridge in Redding, California that's a giant sundial. Its shadow is so long that it will move 1 foot per minute. And did you know that the Mars rovers Spirit and Opportunity had sundials on them? Bill Nye, the science guy, was involved in designing those. So let's make our own sundial. So included in the notes of the video is this template. And I suggest that you print out 2 copies of the template because the instructions will eventually get folded and you won't be able to follow along. So the instructions are actually pretty clear. The first step is to cut out your nomen. So you'll notice there's dotted lines right here, like that. And then you are supposed to cut at these little dotted lines, not all the way up, just a little tab at the end, like this. So here is what it will look like. Little tabs at the end. And then you're going to fold it in half and fold it in half again. And notice, once you've done that, those little tabs at the end are going to become the feet for how you attach your nomen to the sundial. All right, so you've made your nomen. The next step is to fold your sundial or your plate. So first you want to cut it out. So you're just going to cut here and here. Like it says, don't cut past here. So you'll cut here and here. And then you're going to fold along this line, and this line. And I have in my example here, I've started that process. So I've folded along those lines. And then the next step is folding along the side. You're going to be making kind of a ramp shape. And this is where you need to pay attention to what latitude you want to use the sundial at. So in Michigan, we're at latitude 42. So I actually used a ruler to draw a line between 40 and 45 to be slightly more accurate. And then you're going to fold along that line. And notice now we will be able to complete our ramp shape by just taping in the back. And I'll spare you the details. Everyone knows how to use tape. But just get it straight as you can. You want it to be a nice straight side, and you want the other side to be nice and straight. And then the final step to assembling your Nomen and sundial is to actually attach your Nomen. This step is a little bit fumbly, but they have helpfully included little markings for where those tabs, those feet of your Nomen are going to sit. So you may want to get a little bit of help from somebody. But I'm just kind of positioning it in place, and then I would use small pieces of tape to attach it. You want the Nomen to be nice and straight. And here's what the completed Nomen looks like. Or the completed sundial, sorry. I've got gnomes on the brain. So I promised you I'd talk a little bit more about latitude. So here on my globe, see these imaginary lines kind of horizontal around the globe? Here, the center belt of the globe, that's called the equator. And in Michigan, we are at 42 degrees north of that equator. My little globe is tiny, but about here. The North Pole is 90 degrees north. So it matters where you are in the globe, the way that the sun appears to move. It's going to hit the Earth a little differently depending on where you are in the globe. And so your sundial needs to take that into account. And sundial mathematics is actually a little more complicated, but I just want you to remember that the latitude does matter. All right, so we're going to wait for the sun to come out, and then we'll be able to position our sundial and see how it works. So you want to put your sundial in a nice flat location, and keep in mind, depending where you put it, the buildings nearby might cast a shadow. So think about that a little bit when you're positioning your sundial. So for me, a nice flat spot is on my deck. And you want the 12 noon part of your sundial, you want it to point north. I used a compass app on my phone to check that direction. You can also use a more simple compass if you have one. So I've marked a spot, and I'm going to weigh down my sundial a little bit because it's just paper, it's not heavy enough. And we'll zoom in and you can see the shadow cast by the Nomen. And it's, according to the sundial, a little bit after noon. Since we're in daylight savings time here in Michigan, I need to add an hour. So it's actually a little after 1 in Michigan on daylight savings time. So keep that in mind as well. So how accurate is your sundial? I did test mine and found it was pretty accurate at the 1 hour and 30-minute marks. To get more accurate than that, you'll need a much fancier sundial with a more elaborate dial. And also you'll need some more corrections, not only for your latitude, but also your longitude and the time of year that you're using the sundial. So here is another pattern you can make. This is a more classic looking sundial. You'll notice the plate is horizontal and it's the Nomen that's at the angle. This particular pattern is available from the North America Sundial Society at their website, and I will have a link in the video notes. The nice thing about this sundial is that you'll input your latitude and it will draw a pattern for you that you cut out. And this one's attached to a piece of thin cardboard like a cereal box. And so here, this particular sundial, again, we want to orient it so that it's pointing to noon-ish. Towards north. And I could line it up a little bit better. I'm going to weigh it down. It needs to be flat. It's a lot more sensitive to how flat the surface is, but that's another pattern that you can make if you're interested. So, another fun fact, not only can the sun's path be used to track the time of day based on the shadows that it casts, you can also use the sun's path to track the seasons. And ancient people built monuments and structures based on that knowledge. The most famous example of this is Stonehenge. That's that standing stone circle in England, built 3000 BC. And so one of its alignments on the summer solstice, which is around June 20th every year, the longest day of the year, on the summer solstice, the sun rises over the heel stone of Stonehenge. Something that's amazing to me, how did ancient people figure out to the accuracy that they needed where the path of the sun was going to be? I'm just amazed that they did that without modern tools. Another example that's pretty famous is El Castillo, which is a Mayan pyramid in Chichen Itza, Mexico. It was built about 1,000 years ago, and its particular sun alignment is during the equinoxes, which is the spring and fall time around mid-March and mid-September, when the day and night is equal length. A shadow descends on one of the stairs of the pyramid. It kind of creeps down like a snake, and then the sun is at the top of the pyramid like the head of the snake. It's really cool. So modern people have also built buildings that showcase the sun's path, but not always on purpose. So for example, cities that have east-west street grids, in some of those cities, skyscrapers have been found that perfectly frame the sunrise or sunset at particular times of year. If you're curious about that, I would suggest that you Google Manhattan Henge or Chicago Henge to learn more. Happy sciencing.